the next type of radioactive decay is called beta decay. And the symbol for this is a Greek beta. And beta decay is more energetic than alpha decay and more dangerous. So again, you would have some nuclei that's unstable. Here, let me do one of my favorite ones. Here's tritium. So there's a proton and 3 neutrons. And this can spontaneously emit a beta particle, which we'll call that, like that. And that little negative sign indicates what the beta particle is. And it is simply a high energy electron. Now, let's look at this process. Well, okay. Anyway, so this high energy electron comes out, and if it hits you, it can damage your DNA, and that causes things like cancer and stuff like that. Now, beta radiation is more energetic than alpha radiation, so you need to wear thicker gloves and thicker clothing. But generally speaking, it's not that bad. And if the other thing about dealing with radioactive stuff, let's say you're holding something radioactive, you want to be wearing gloves because you don't want it on your skin, because if you get the radioactive stuff on you, then it's emitting those particles right on your skin, and you definitely don't want to get it in you, because then it's emitting that stuff right inside your body, and that's dangerous. So that's some of this, how you have to handle radioactive stuff. But anyway, so you get this electron, but there's more to the equation. You have a new nuclei now. This atom here has turned in to this over here, which is, now you've got 2 protons and 2 neutrons, but what happened to that 3rd neutron? That neutron, you started with the neutron, and it became a proton. So it also emitted an electron, or a beta particle. So look what happened. You had a neutron, it turned into a proton and an electron. That should tell you something about the neutron. It has a positive and negative charge in it, bound together somehow, and so its net charge is neutral, but if it decays, it can emit this proton and this beta particle. The proton stays in the nucleus, the beta particle comes out as radiation. Now, in some of these reactions, a 3rd product is produced, and this is the bad one. Sometimes, and I don't know if this is correct for this equation, but I'll just throw it in here, sometimes another particle called a gamma particle is produced. Now, a gamma ray, let me redraw my gamma. There you go. There you go. Something like that. Gamma. This is gamma. A gamma particle is released. Now, let's be careful. It's not technically a particle. It's a quote-unquote ray, a gamma ray. And the reason we say that is because what the gamma ray really is a high-energy photon. So gamma rays are high-energy photons. And you have to be very, very careful with gamma rays. The reason is they can penetrate, depending on their energy, through even lots of lead. So you have to, that's why, for example, if you've gotten an X-ray before, they'll make you wear a lead shield. That's because X-rays are also high-energy photons, just not as high energy as gamma rays. So when you're dealing with stuff that's gamma emitting, you need to be very careful. You need to wear lead, you need to be far away from it, and not touching it and stuff like that. So the three types of decays are alpha decay, beta decay, and gamma decay. Alpha, beta, and gamma. There is also another type, which is called positronic decay, or positron decay. And basically, instead of a neutron becoming so the one we talked about was when you have a neutron, which becomes a proton plus a beta particle. You can also have this one, which is a proton can become a neutron plus a positron, which is a positive electron. Positron. So there are positive electrons out there. Now, so those are the three types of different radiations that can occur, and we have to be careful with the word radiation. Let's talk about it for a minute. Radiation. All the word really means is stuff that comes out of something else. Roots radiate away from a tree. Sunlight radiates away from the sun. Heat radiates away from a hot object, radiant heat. So not all radiation is quote-unquote bad or bad for you. I like the radiation that comes from my wood stove very much. So when we're talking about nuclear radiation, that's what we want to stay, again, can't write up close. Radiation. Nuclear radiation is generally dangerous, whether it's alpha, beta, or gamma, and you want to avoid it. It has medicinal purposes and uses. It's good at killing cancer cells, which is great. It's a good thing. It's a good use of this radiation. So it can, when used properly, it's a good thing. But then we got to be careful because you have electromagnetic radiation. Did it again. Did it again. And I popped this thing off too. There we go. So electromagnetic radiation is simply things like radio waves. And so, radio waves are fairly harmless, though it's not clear that cell phones are necessarily fairly harmless. There are microwaves, which are just concentrated radio waves of a certain frequency. And again, you don't want to put your hand near a microwave source because it will burn it from the inside, which is bad. But again, we use microwaves for all kinds of communication and stuff like that. So your cell phone is actually in the microwave band. It's not necessarily cooking your brain. There are people who claim that. It's not clear from the research, nor is it clear that any clear research will ever be done because of the financial stakes that would be involved in saying that cell phones were bad for you. There are light is a form of electromagnetic radiation, and interestingly, even the gamma rays from nuclear energy are actually a type of electromagnetic wave, just very, very high energy, very high frequency. So that's nuclear radiation and electromagnetic radiation. So you just have to be very specific. When you use the word radiation, you got to know what you're talking about, because it's not all dangerous and it's not all a bad thing and it's not all nuclear. So let's talk about now some of the uses for. I'll let you read about the medicinal uses in the book, but I want to talk about the nuclear energy uses and also how we detect radiation. Let's do that first.